them for both integration as well as classification problems. With help of KNN, we can solve the both problems like regression problems as well as classification problems. Okay, so I would like to go for explain about this KNN, and so it was very simple thing. So nearest, so for example, if we have some kind of classes, which class which could be near, okay, then based upon that neighbor, okay, based upon that one, it will be go for classify it. Okay, so a KNN classifier is a very simple and easy to understand the machine learning algorithm. Okay, in this particular kernel, so what exactly we are going to do, actually we are going to be building the K nearest neighbor classifier. Okay, so it will be classifying the, okay, patient suffering from the, okay, cancer. So there could be different kind of cancers are there, malignant cancer and benign cancer. Okay, so we would like to go for classifying whether it which is a class, which type of cancer is suffering it. Okay, for that one we are going to be choosing the K nearest neighbor algorithm. Okay, so let's go for understanding that how that K nearest neighbor algorithm is working. Okay, so basically K nearest neighbor algorithm is the non-parametric algorithm. Non-parametric algorithm means it does not need any kind of assumptions actually. Okay, so if when you want to do some kind of when you want to apply the some kind of algorithm on your data, make sure that you should follow some kind of assumptions, right? Okay, but when you want to do a KNN classifier, you don't need we don't need to met any kind of assumptions actually. Without any assumptions, we can start building the a model. Okay, so that's the reason we are calling it a KNN is the non-parametric algorithm. Clear? So, this is the algorithm we can use for both classification problems as well as regression problems. Okay, see how this will works actually. The input consisting the K closest to training example in the feature space. The output depending on the KNN, whether KNN used for classification or regression purpose, that's fine. But how this is the algorithm is working, it's a totally depends upon the k in the sense it's some kind of number. Okay, let me take a small example so that you can able to understand. Yeah. Okay, so for example, this is the one classifier and this is the one classifier. Okay, so this is the classifier, you can feel it's 0. This is the classifier, you can feel it's a 1. Okay, for example, you took some kind of you took some number, okay, that it could be the k. Okay, for example, if my k is the 3, okay, so I have some new point. I have, this is my new point actually. Okay, this is my new feature. So whether this is the feature, whether it is the class 0 or else class 1 or class 0. Okay, for example, if I fix the k value some odd number, or why odd number, in the sense it won't tie. Okay, that's the reason we are taking the k value is always odd number. For example, if I'm taking the k value is a 5, okay, so I can find the 5 nearest things. This is the, for example, here there is a points, here it is a points. Okay, and here we have some points, and here we have some points, right? And so this is my new feature. I would like to go for finding the k nearest points. That means 5 nearest points. This is one, and this is one nearest point, and this is one nearest point, and this is one nearest point, and this is one nearest point. From this 5, these are the 3 are the very close to this particular feature. So based upon this concept, we are saying that this is the new feature which belongs to the this class 0. Clear how the k nearest neighbor working? It totally depends upon the nearest points, Euclidean distance, the distance between the new point and the trained model. Okay, the class. Is it clear? The KNN classifier, the output class membership, the given data classified based on the majority type of its neighbors. So which is the feature which the feature which is more majority neighbors we have it, which can be belongs to that specific class. The data point is assigned to the most frequent class among its k nearest neighbors. Usually, k is a small positive number. Okay, k is what? It's a small positive number. Okay, if k equal to 1, then the data point is simply assigned to the a class of the single nearest neighbor. Clear? And in KNN regression, the output simply some property, okay, value and object. This value is the average value of the k nearest neighbors. So this is the k value. Ultimately, it was depending on the user. So you can fix it, which is the k value you want to be make it. It's up to your choice actually. Okay, when you want to do some kind of KNN classifier, mostly we would like to see lazy learning, okay, or else lazy learning or else eager learning. Okay, there could be two type of learners we have it when you want to do some kind of KNN. So lazy learner in the sense you don't have any kind of training data. Okay, so simple thing is lazy learning in the sense the KNN is a type of instance based on the learning or else lazy learning. Actually, lazy learning means you don't need any training data points for generating the model. Okay, if you want to be generating the machine learning model, you don't require the training data. Okay, if you don't have a training data, then what happens? All training data will be used in the testing phase only. So when you are do some kind of testing, by the time only we are going to be using this particular training data. Okay, this makes training was very faster, but the testing could be slow because of you're not even training the model, right? So that the training time it could be very slow. I mean the training it could be the fast, but when you want to do some kind of testing it could be the slow because of it was having the both training and testing data. So that's the reason it could be slow and it could be a costlier. Okay, so the testing phase requires the more time and more memory resources because of most data is available in a testing data, not at a training data or not at a model training. Clear? So here KNN, the neighbor is taken from the set of objects for which the class or the object property is also known. And so I think it's a very simple thing. It's you don't need any kind of training data, and with the testing time only we are going to be using it. Okay, and the k nearest neighbors intuition. It's a very simple and understand, and it was calculated the distance between the new sample and existing sample. Okay, so the sample data and all other training data points, the distance you can call it as a Euclidean distance and Manhattan distance actually. Okay, then it can be selecting the k nearest neighbors, k nearest data points, and based upon k is basically it's a integer number and it was assigned by the user only. Okay, and basically k it could be the odd number. The reason is that it won't be never tie. That's the reason we're going to be using the k value. It could be a odd number only. Okay, for example, if k value is the one, then it's not k nearest neighbor, it's a nearest neighbor algorithm. It's so we can call it a nearest neighbor algorithm when k value it could be 1. Okay, yeah. So how we can deciding the number of neighbors in KNN? So it's a, I already told you it's a totally depends upon your choice actually, or else cross validation technique we can use it. So eager learning and lazy learning. Lazy learning in the sense you don't need any kind of training data. Without any training data, we are going to be generating the model at a testing time only. Okay. So eager learning in the sense, so we are giving the training data points. Okay, we are going to be constructing the generalized model before we are performing any kind of prediction with any new points actually. Okay, so we would like to go for creating the generalized model with the help of the training data. Okay, in we can think of such learner is being ready and active to eager to classify the new data points. So you have already created the model, right? So it's a eager to wait classify the new data points, so that we are calling it say eager learning. Lazy learning in the sense you don't need any kind of training data to creating the generalized model. Okay, by the time of prediction only we are going to be uh, testing with whole data. So when you want to do some kind of KNN classification, we require some kind of libraries, right? So the libraries are NumPy, Pandas, and Matplotlib. These are the libraries. It can help you to do some kind of applying the data processing or data visualization or do some kind of linear algebra things. Okay, and we are working in the Kaggle, so that if you want to access the data sets from the Kaggle, make sure that we should use the Kaggle input over here. Okay, we need to join your your directory. So when you are joining with your directory, so the data set which is available, in input, UCI, breast cancer, and Viscon original, and this is the folder. Inside of this folder, we have the text data is there. Okay, we are giving the path of this particular data, and this is the data we are providing to the read underscore CSV method from the pandas. So this is the way we can able to read the data. So basically the data set which is not having any kind of header, so that we are simply off your header actually. Okay, and by the time of providing the data, what column could be belongs to which column, so that names and everything could be provided by the project manager. So that's the reason I have to specify the column names by manually. So this is the way you can able to specify the column name for that particular data set. Okay, so from this one, the last could be your dependent variable, rest of all thing it could be your independent variables. Okay, let me go for check head in the sense first 5 records it can be show us. Okay, and I would like to go for dropping the redundant data in the sense I don't need index, right? Index you don't need it, right? ID you don't need it, right? So that I'm simply dropping that ID column from my data frame. So I would like to do some kind of summary of your data set. So simply if I go ahead with the info function, it can be providing the data type of each and everything, and is there any kind of null is there, and how many number of entry points we have it, and how many number of columns we have it, everything we can able to describing in this particular method. So with the help of the info function, we can able to describing the entire data set. So here we don't have any ID column. The reason is that we already removed it in a previous step. Now here we have the frequency distribution of the values in a variables. So simply what I'm doing, actually I'm taking each and every column and I'm finding the value of count each and everything. For example, this is my first column. The name of the column is clump thickness, and here I have the 1 and 5, 3 and 1 2 3 4 up to 10. There is a 10 thicknesses we have it. Okay, each and everything thickness, how many number of data points we have it. And meanwhile, and uniformity cell size. Okay, uniformity cell size also we have the 1 to 10 we have it, and for each one how many number of records it might be repeated, that also we can able to look in this particular method. Okay, this is the way each and every column we are taking and we are giving the value of
I just have a question. So you mean for each type of
sorry.
feature? So the question I have is, so for each type of feature, for example, there are 443 points. Is it
Yeah,
like
one
the first
is
one,
nothing but it's a
145 points?
one is the one data point. Okay, the data point which is available in this particular this is the column thickness, right? This column thickness we have the total 699 records are there. Out of this records, so there is a 10 points are repeated continuously, 1 2 3 4 5 6 7 8 and 9. So each one how many times which is repeated, that we are going to be displaying, or which we are going to be returning in this particular method value
So
count.
basically, which means that one is repeated 145
Frequency,
times.
one is frequently
Okay.
repeated 140
Okay. Got
145
it.
times. Okay,
Okay.
so one is here it is repeated 384 times. Here one is the one data point of uniformity cell shape, and which is repeated 353 times. Okay, so this is the count of each and every value. If you sum of this all, it could be 699. Okay,
Okay. Got it. Yeah.
so when comes to the last one, it could be my class which is having only two records. One is the 2 and one is the 4. My 2 is repeated the 458 times, and 2 is repeated the 458 times, 4 is repeated the 241 times actually. Okay, so this is the way we can able to show you, the frequency values. Okay, or value count each and every data point. The same thing we can able to display in the graphical point as well. Anyway, now what I'm doing, actually everything I would like to converting into the, okay, so numerical format. This is the bar nucleo. It was in a different time, different data format, you can see. So this is object format. You just simply say this one. This is object format, right? Even it is object format, but it was showing me like a number format or not. Okay, 1, 10, 2, 5. This is the number only, right? Even it is the number, it was showing. Sorry, not here. Yeah, actually, this is the object type. Before that, when I run it 2 times, that's the reason it was showing me like, object format, integer format. So actually, this is the statement. With help of this statement, we are converting your object form to integer form. Okay. So once if you are converting into the object form to integer form, then everything could be it's
And
integer
what is
format.
that? What is that we are using that error when your conversion, right? That line error is equal to coerce or something.
Even it
What is that?
don't need actually. So it's error is one object. It's a covariance. Okay, it was converting exactly the same thing. Okay, and so now here we have the everything, it could be converting into the integer format. So here we have is null function is there. With help of the is null function, it can show you is there any kind of missing data, do you have it. Okay, so unfortunately my bar nucleo, which is having the 67 16 null values are there. Okay, 16 null values are there. See why we are using error in the sense, see some of the points, some of the points, some of the data points which is not integers, it was having the null characters. Okay, so this is the bar underscore nucleo. This is the column which is having not only numbers like 1 2 3 4, but we have some data points are null, none, or nan, none. Okay, that is the data point which was repeated. Okay, by default it was object, that means it's a string nan is repeated. Okay, because of that one, if you try to be converting that integer to numerical, then you will be getting the error. Okay, so we are overcome this error actually. Clear my point? Clear or not? Hello, someone is asking the question regarding about why we are using error over there.
I was the one who asked that.
Is it Shalini, right? So
Yeah,
Shalini,
yeah,
you cleared that. Did
yeah,
you
yeah, yeah.
you got it right? Why we are
Mhm.
using arrow over there? See the column, that specific column which is having the 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10. But along with 10, we have one more data point is repeated 16 times, which is NaN. Usually in a machine learning, NaN means none. None means nothing, no data. But unfortunately, it was object type. That means NaN, it was not none actually. It was string none. So when you are converting string none to integer to numeric, then you will be getting error. So if you want to overcome that one, we are going to be using that error object. Clear?
Okay, yeah, got it.
Okay. So now I would like to go for checking, is there any kind of null values are there? Okay, yes, of course, I have some kind of null values are there in this nucleo. Okay, and I want to check it. Is there in total number of null values in testing total data frame is null. Okay, total is null and is null both are same. Okay, both are used for to checking the null only. Is null and is null both are same. Clear? Sometimes it was null, sometimes it was nan. So now what I want to do, actually I would like to be find the, okay, I would like to be find the nuclear distribution. So it was showing me like, 1 to 10, it was some values are there. So now what I can do, you can able to find the unique things. When I do the unique things, which is having the nan, right? Okay, this is the nan which is repeated 16 times. You have to be convert that, so there is 16 nan is there. So with help of this one, you are finding the how many nuns are there. There are 16 null values are there. Those things we can say it's a missing data. So when we have missing data, then we need to handle it. How we can handle it? So one, it could be removal. Second one, it could be replacement. So when you want to replace it, make sure that we can use either median or mode, okay, or else mean, median, mode. Okay, these are the things we can go for use it for replacement. And meanwhile, is there any kind of outliers are there? Okay, so for finding the outlier, so we are going to be giving the describe for each and everything. So there is a count, it could be 667, and max value is the 10, and min value is, it could be the 1. Okay, median, mode and everything we can able to find it, but everything it was 0 to 1 only. So there is no outliers in this particular data. Even if you have outliers, even if we have a missing data, so it was very simple thing, you have to use the replacement process. Okay, and for more understanding the univariate, for understanding the distribution how it was, for that one we can we are going to be creating the total 10 diagrams. Okay, and that each diagram, why we are going to be creating the 10 diagrams in the sense, the reason is that we have a 10 features we have it. Okay, so from this 10 features we are using the histogram, and okay, so 5 comma 2 in the sense 10, and we are total we are going to be plotting with help of the data frame dot plot. So it could be the frequency of the chunk thickness, and this is the frequency table for the uniformity cell size. So this is the way you can able to go for look the, okay, distribution. But unfortunately none of the data it was normal distributed. Okay, there is no normal distribution data now. So this is the univariate analysis. Univariate in the sense we can able to go for visualize only one diagram. Okay, one feature we are going to be analyzing only one feature. Multivariate in the sense we can able to go ahead with the correlation graph or correlation coefficient. Okay, so my class, which is depending on the bar nucleo with 82 percentage, and the uniformity cell shape is 81 percentage. So these are the things are mostly the class which is depending on the everything, on every feature. Okay, that means these are all features it was influencing on our cancer. Okay, out of that one, mitosis is very less influence. So that kind of explanation I mentioned over here. And if something which is -1, that means it's a very strong relation but negatively. +1 indicating that it's a very high correlation with the positively. That's what it is saying us. Okay, and we'll go with some kind of patterns and relationship. So this is the heat correlation heat map, or this is the heat map, and this correlation heat map, it is showing that is there any independent variable is depending on the any other independent variable. That kind of things we can able to find out with help of the correlation matrix. Okay, so this is the same thickness which is correlated with the uniform cell size, which is 0.64, right? And uniformity cell shape also, it could be depending, so like 0.65. That means there could be some kind of relationship between the cell size and cell shape with thickness. And moreover, this is the chum thickness, it was depending on your class with 0.72, that means 72 percentage. This is the way we can able to mention our heat map, and we can understood what is the variable which is more dependable. Okay, and I would like to go for defining the what could be the x variable, what could be the y variable. So I am considering the y, it was my class, and x it was except x everything it could be my x data, and only I'm considering the y is my class. Now I would like to split your data into training part and testing part, and I can find the shape of it, but you have some kind of null data is there, so you can able to replace it. There could be 13 null values are there in training data. There could be 3 null values are there in testing data. So now what we can do, actually we are replacing that mean value wherever we have the null, so we are replacing with mean. Okay, that we are doing with help of this step. So after that one, I already told you we don't have any specific assumptions, but anyway you can able to go for fill with mean values or median values whenever we have some kind of null values. Okay, either we can able to go ahead with the, this is the training data, right? For testing, this is also training data. So what we are doing, actually we are taking the, we are going to be creating the, okay, either we can use the, either this method, either you can go ahead with the this method. Okay, either we can use median or else mode. So anyway, finally what we are doing, actually we are, would like to go for checking is there any null, but unfortunately before we are checking this one, we are replacing that wherever we have the null, right? Okay, I can say that we don't have any kind of null data in both the testing data and training data. Then we are going to be creating the, or we can able to go for apply the feature scaling. As of now we are not even apply the machine learning algorithm, guys. So this entire feature scaling, in the sense every, the entire data, it could be in a same square. So when you want to make it everything it could be the same square, then I can use the standard scalar or min max scalar and other things we can use it. So with help of the standard scalar, we are converting the entire data, it was in between the -1 to a +1. Okay, and this is the way we can convert the entire data in between -2 to +2, actually. Okay, yes, -2 to a +2. So, or -3 to +3, maximum is in between -3 to +3 only. Okay, so the entire data now it was a normally distribution. Okay, if it is a normal distribution, then we can go ahead with the logistic regression. We can apply the logistic regression, we can apply the KNN regression, we can apply the support vector classification, anything we can apply it. But in this example we are going to be looking the k nearest neighbor. So to, if you want to work with k nearest neighbor, now what we can do, we can able to go for importing the k neighbor classifier, and we are specifying that how many number of k values we are going to be using it. So how many number of k values we are going to be using it, that could be the more accuracy it is. Okay, the accuracy which is depending on the k value. If k value is increases, it could be more accuracy. Clear? So the instance of the model, and we are creating the model and we are training the model. Once if we are training the model, we can able to go for predicting the some new points. This is your new data, new predictions, and y test, it could be your old prediction for the corresponding x data, and this is your prediction with your model. Okay, so I can able to find the predict score probability of each and everything. So 1 indicating that it is strongly that one. Okay, 0 indicating that it's not that one. Okay, so there could be, you're going to be giving the probability of each and everything as well. Okay, so now we would like to go for checking the accuracy. I would like to go for checking the accuracy with the test data. It was 97 percentage, and with training data also we can able to go for checking the accuracy. It was 98 percentage. So it was not overfitting, not underfitting, actually. So both are in the same score only. Okay, approximately same. So even if you're having the good training and testing is giving the high accuracy, we cannot conclude that my model is good. So how you can able to, my model is good, so based upon the null accuracy. Okay, based upon the null accuracy. Null accuracy in the sense, we would like to go for finding the most frequent, most frequent by the, okay, sum of most frequent samples by the sum of total samples. Okay, there could be 85, right? It's a most frequency. Okay, 85, and so total it could be
I think
85 plus.
I didn't catch the null frequency. Can you?
See, here we have the test
Yeah.
accuracy and the train accuracy, it could
Okay.
be very high. Okay,
Mm-hmm.
so people can concluding that my model is good based upon this accuracy scores, but that's
Mm-hmm.
not a correct thing for every situation. Okay, there could be some kind of classification matrices we have it. From that one, comparing the model accuracy with null accuracy. So when you are comparing with model accuracy with null accuracy, if it is the reasonable null accuracy, then my model is good. If null accuracy it could be the less than the 0.5, then you can say that your model is not good. Okay, I mean what accuracy we are getting for your model, that is not best. So you're going to be comparing your model accuracy with null accuracy. Here my null accuracy is most frequency, so 85 is the
And
most
how are we are getting the null accuracy by doing the value count, is it? I didn't understand that part.
null
How?
accuracy function is to frequency, most frequency class. Most frequency
Okay.
class is 85 in this particular
Okay.
example. Okay,
Uh,
by
okay.
calculating the total accuracy, total value, 85
Okay.
plus 55. Most frequency is what? 85, right? So that 85
Mm.
by, for example, in place of 85, if we have the 40, then we should take the
Okay.
55 is the most frequency. Okay,
Got it. Okay.
so 85 by the 85 plus 55, then we are getting the null accuracy score is 60 percentage. This is the evidence is that your model accuracy is good. If your null accuracy is greater than the 50 percentage, then we can say your model accuracy it's good. Okay,
Yeah, I got it. Okay.
yeah, so this is the way we can able to go for finding the
So
accuracy score.
is it just for KNN that we do this comparison with
Everything,
null
every
accuracy or for
classify
all models?
every classification
Okay.
technique. Okay, there
Okay.
could be some kind of matrices are there. The matrices are, I can show you. Anyway, for the rebuilding of the KNN with a different k value, previous example I took the k value is the 5. Instead of taking the 3, I just took the 5. Now I can train the model, and I can predict the prediction with new test data. Okay, I can find the accuracy with this one, and meanwhile I can find the rebuild the model with k value is the 6. But usually k value is never even numbers, don't use even numbers. Okay, so most of the situation it was time, so you won't get the good results. Okay, so that's the reason always the my k value it could be odd number. For different k values you can able to check with the model accuracy. And finally, how you don't know which k value I should use it, right? For that one we can able to go for using the um, cross validation technique. That cross validation technique I can show you in a after that one. See, this is the way anyway you can able to go for finding the different models. And now confusion matrix is the very important thing. Okay, so this confusion matrix, we just providing that your y test and your y predicted, then which is generating the matrix. Actually, this is the matrix which is having the 4 points. One is the true positive and true negative. This is true negative 0 0 1 0 0 1, right? It's a false positive. Yes, this is false positive. This is false negative. This is the false negative. This is false positive. Okay, so this is the way you can able to creating the matrix. So this matrix is 83 is nothing but it's a true positive, and 53 is the true negative. Okay, this 2 is the this 2 is the false positive. Okay, and this 2 is the false negative. This is the my false negative. So this is the values. With help of these values only we can able to go for giving a lot of information, like precision. This is the report precision recall f1 score. This is the values are depending on the this confusion matrix, so how we can able to calculating the how we can able to calculating the accuracy, total true positive plus true negative by the total number of samples, right? So that it's a 97.86. This is a model accuracy. Okay, and the classification error in the sense false positive plus false negative by the total thing. This is the error rate. This is your error rate. Error rate it could be very less. So precision precision is the concept. It can giving the the percentage of the correctly predicted positive outcomes out of the predicted positive outcomes. So true positive by the true positive plus false positive. This is your predicted positive, right? Some are the positive, true positive, some are the false positive. So this is your predicted positive. So true positive by the predicted positives, that we are calling it's a precision. Okay, so if this is a precision, and this recall will help you. Okay, so your model is good or bad as well. Okay, recall in the sense correctly predicted by the total actual positives. So that's the reason true positive by the true positive plus false negative. This is the false negative plus true positive. It's a total positive things, actual positive things. So with the help of this precision and recall, if it is a more, then your model is good. 100% your model is good. In the meanwhile, we can able to go for specificity in the sense true negative by the true negative plus false positive, that we are calling it as specificity. And F1 score in the sense it's harmonic mean of the your recall and precision. So this is the way we can able to go for calculating the F1 score also. And this is the matrices, it will help you to finding the ROC and AUC curve. If you plot the precision and corresponding precision precision and specificity, so true positive false positive rate by the specificity, that we are calling it as specificity. Okay, and sensitivity, and this is a specificity and specificity and sensitivity. If you plot it, that we are calling it a ROC curve. If the ROC curve, it was the up direction, okay, this direction, that means it's a good. Sometimes this ROC curve, it could be very like this one. This means which is not model correct. It's not, my model is not correct. Okay, when my ROC and ROC and AOC curve, which is giving something like this, that means it was 100% your model is good. Okay, without any deviation this line, if it is giving this kind of line, straight line or horizontal line, that we are giving, that it's our good model. Okay, with help of the ROC and AOC curve also, we can able to say, we can able to confirm that our model is good. Okay, this is very very important, guys, when you are working with uh, when you are working with the classification techniques. This ROC and AUC curve, it could be very very important. Okay, and some situation you don't know how we can able to calculating the K value, right? So that we can go ahead with the cross val score or K fold cross validation. So with help of the cross val score, we can able to fix it total cross validation. That means you're going to be repeating the 10 times with the same data training. Okay, or training data. By the time it is providing that for each time which is providing that, some accuracy, right? This is the accuracy of each and every situation. That means when you are giving this one, that means your model what we created with 7 K values, we are training 10 times with the same data set. By the time we are going to be calculating the accuracy, and this is the cross validation score. So average of this one, we are calling it say cross validation score. Okay, so the mean is, it's a 96 percentage, your model is good when you do the cross validation. So this is the way you can able to go for build the any kind of classification algorithm, guys. Clear? And I would like to providing this, you can go ahead with this code. I can provide you this link in your canvas, and try to be work with this project, KNN classification project. Okay, okay, that's for machine learning
Do you
class.
have similarly, do you have a KNN class for regression by any chance? Just to go through
Mostly we are
the
not using regression actually. So most of the time we are not using the KNN, but we can use the KNN as a regression. But most of the time we are going to be using the KNN for the
okay.
classification
I just
technique.
wanted to know if you have any sample where I
Yeah, of
can,
course I will show you
like
if I
where
have.
the
At this moment I
yeah
don't have a specific data set and other
yeah,
stuff,
or if you
but
can just
we can.
provide that link in the
Yeah,
Kaggle.
sure.
I mean
Yeah.
in the this thing in your
Of course, we can use in a regression as well, but mostly we are going to be using the for classification situations, this KNN. Okay.
yeah.
Yeah. We can use both regression classification, but out of that one, the mostly used in classification techniques only. Okay. Yeah. Anyway, that's for today's session, guys. And we'll meet in a Python session. Who are coming for Python session, you can come to the Python sessions. Okay. Yeah. Bye. Take care. See you. Take care.